Table definitions underpin all the tabular interfaces in Core, exchanging data with IBM doors, importing and exporting CSV files, and publishing tables directly to Microsoft Word. A common approach and a shared set of table definitions is used by all of these mechanisms, enabling a define once, reuse many times mentality. Table definitions are very important for these types of imports and exports, as they determine where the data either comes from or goes in the system repository. To access the table definition dialog, use the import command to import a DOORS or CSV file, or the export command to export to DOORS, CSV, or Word. I will choose to export a file to CSV so that we can define a table definition. To do that, I will navigate through File, Export, to CSV. Once I do that, a dialog will come up which will ask what data I would like to export. You can choose to export the entire database, a specific folder which includes all subfolders, or a package which includes all subpackages. I will select Component. Clicking Next will take you to the table definition dialog. This dialog will default to one of the predefined table definitions. The drop-down at the top left under Stored Definitions provides access to the available table definitions. You can use these as they are, or you can edit and save your own definitions. The included definitions are for common uses and are also great for guides on defining your own. When you select a table definition, it will populate the main body of the dialog. In the top right, you will notice a Sort Block and Filter option. This will apply a chosen sort block and/or filter to the data from the previously selected folder. This is useful when you are exporting information such as requirements and want to see them in a specific order, or want to output a subset of your requirements, such as all requirements with a type equal to design decision. To create your own table definition, select one of the existing table definitions and then proceed to edit it. I will remove all of the entries by using the X at the far right of each line so that I can start with a blank definition. Now that I have everything removed, I will add a new entry by using the plus option at the top right of the dialog. When editing or adding entries, the position drop-down at the beginning of each line determines which column data is entered. So, position 1 will be the first column, position 2 will be the second column, and so on. In the first column of the output, I would like to have the number of the element. To retrieve that from Core, I will make sure that the type is set to attribute. The type defines what type of information is retrieved. For example, an attribute, a relationship, relationship targets. There are a number of types to ensure you get the information you would like. With the type selected as attribute, I will then select the specific attribute. This selection determines which attribute value to output. In this case, I will choose number so that we can output the element's number. Depending on the type selected, there will be different options available. As you can see here, the sort block option is grayed out along with output as single cell. This means that for the selection we have, those options are not valid and in turn are not able to be set. We will cover these in a bit more detail when we have an entry where these options can be used. The Based On option determines the source object for the entry in the table definition. This can be based on the data itself or other columns in your table definition, columns that are either above this entry or below this entry. Since we currently have one entry and want to know the number attribute of the elements that are in our data set from core, we will leave this set to data. Header allows you to input a text value for the first row of your column. This is pre-populated based on the type that you have selected, but can be changed as desired. I will leave this as the default. Repeat values is an option that can be used to repeat data for rows in your table. For example, if column 1 is a requirement, column 2 is the requirement's children, and column 3 is the description for the child requirement, you will likely have many child rows. With this option checked for column 1 in this instance, it would repeat the requirement for every row. If it is unchecked, the requirement name will be output the first time only, and subsequent rows will contain a blank cell in the column. I will leave this checked for our entry. In most cases, we want columns to show up in the resultant table. Sometimes we need a column to serve as a source for another column, but we do not actually want to display the source column. Unchecking the Show Column option will not output the column where this option is selected. I will leave this checked for our example now. Now that we have our first entry defined, we will add more so that we can get additional information from the model in core. I will click the plus button to add a second entry below the one we have already defined. Again, if you add things and want to change the order of the columns, use the position drop-down at the far left of the entry. For our second column, we want to retrieve the element name. To do that, I will select my type as element. This type will get the element name from the database. We do not need to set a definition because this entry type is specific and that option is not available. You can see that this particular type has a sort block that can be applied. The other types with sort block as an option are relationships and targets. The sort block determines which sort block will be used for the entry that can sort the data, for relationships and targets, and how the data is output in the column. All defined sort blocks in your project will be available in this drop-down. For our entry, I will select alphabetic. I will leave the rest of the options as default. Note that the sort block outside of the column entries will sort the initial data set. The third entry we want to get from the project is a parameter. I will go ahead and add a new entry to our table definition. After I do, you will notice that when you select a type, there are three different parameter options: parameter, parameter units, and parameter value. Retrieving the parameter type outputs both the parameter value and the units together, separated by a space. Parameter units outputs just the units, and parameter value outputs just the value. For our example, I will choose parameter as it will output both the value and units. Our definition will be power. I will also add parameter : to the header to be more specific in what data this is. With this entry defined, let's add another. In our fourth column, we want to output a relationship. Since we are working with components, I will choose the Built From relationship from the definition drop-down after I have chosen the type. we are going to leave everything set to the default for this entry. Please note, this is one of the entry types that allows for use of the option Output as Single Cell. Since I want each target to be in its own cell, I will make sure this is unchecked. You will also notice a Targets type when you open the Type drop-down. The difference here is that relationships will get the relationship objects that will allow you to get a relationship attribute. The targets will get the targets, which will allow you to continue building using the target information. It is recommended to use targets unless you need to output a relationship attribute in a dependent column. We will be getting the relationship attribute, so we are going with relationships as the type. Our fifth entry is going to be based on the relationship that we are retrieving in our previous entry. After adding a new entry, I will choose attribute as the type and whole multiplicity as the definition. I will then base this entry on entry 4, so we can get the relationship attribute from the built from relationship. Another option when retrieving information from relationships is the targets type. Choosing this will output the targets of a specific relationship. The real power of this comes from basing other entries off these targets. I will add a new entry, and after I do, I will choose the type targets. After that, I will add the definition of specified by. With that entry complete, I will add a new one so that we can output the description of the aforementioned targets. You will notice that after I add the entry, I am changing the based on column to the entry above. Lastly, I want the element ID in the table. To get that, I will add a new entry and select the type as element ID. I would also like this entry to be closer to the class, number, and name of the element, so I will change the position of this entry. Please note that when changing position of columns, the based on positions will change as well. You can see that my attribute entry to retrieve whole multiplicity has now changed to a different based on column since we adjusted the position of this entry. Now that we have the table definition fully defined, I would like to save it. To save a table definition, use the Save option, which looks like a little disk next to the Definitions drop-down. When you click that button, it will ask you to name your table definition. If you name it the same as another table definition, it will overwrite that table definition. From here, I will click Next, and then on the new page, click Export. You may want to format your table in Excel to customize or refine the display. Here you can see the data that we output through the CSV export. All of the data is present based on our table definition. Please note that if a particular definition is not defined for the element being processed, then nothing will be output in the column and no error will be displayed. If you are not getting data when you expect it, please check your model against your table definition to ensure the definition is set up correctly. For more information and resources on Core, please visit our website, open Help contents within Core itself, or contact our support team.